Hi guys, welcome back to the video from the MiniPy projects. Today in this video we are going to talk about one of the essential data structure from the computer science, which is linked list. So in this video tutorial we are going to learn about linked list and how to implement the structure of linked list using Python. So without any further delay, let's get started. So before we start writing the code for the linked list in Python, let's understand a bit about linked list. Linked list is a linear data structure which is composed of the collection of nodes interlinking together to complete the linked list. So linked list is nothing, just a collection of nodes. So over here you can see an example of node. Node is nothing, just an object which consists of a data part and the memory part. When we have multiple nodes, every node is connecting with each other. A single node connected with the multiple nodes with a reference to their succeeding node is called a linked list. The requirement of linked list is just because whenever we save multiple data, every data element saved in a different location. To traverse all the data, we require a reference, and every node consists of a data and its reference, so it can find its succeeding nodes in the memory location. And this chain of interlinking nodes together is nothing, just a linked list. So node contains the data. This is an example of a node where you can see a 10, which is nothing, a data, and the memory location. For now, assume memory do not indicate any of the interlinking nodes. This is an example of a linked list. This is an entire node containing the data and the none part. Another node containing the data and the none part. None part is nothing, just a reference of a next node. So it can help us to traverse the entire linked list and its data. And every node got saved in any of the unique memory address. Let's, for an example, this node save into the memory address of 000. This node gets saved on the memory location of 008. This node 015 and this node 020. Until unless we do not link each node with each other, these are the memory or the data which is present in the memory but in the different location, and we cannot access them. So let's apply the entire linked list logic using the Python and create a linked list. So let's begin with a class node. Class node will collect the data from the user and create an independent node which we gonna use inside our linked list. So class node expect a constructor where we will define the data which is provided by the user. So node will contain a data and its next, which is none. What actually a data is? Data what the user will provide. So node will contain the data, and next is the memory reference for the next node, for which can help us in the linking of the node with one another. And this link of the node is entirely a linked list. So for now, let's make the next to none. Every node, whenever a node is created, it will be independent from any other node. It will have its data and the next part will be none. Now we create a class of linked list. Again, we define a constructor for the linked list class. Linked list class expect nothing, just we define a pointer which is head to none. Now what actually the head is? See, from this example, let's assume these nodes are not yet connected with each other. These are simple independent nodes, right? So we have a one node 10 and its reference none, 20 none, 30 none, and 40 none. But whenever we want to print the linked list, we expect the result to be printed as 10, 20, 30 and 40. But the thing is, how we would know which is the starting point of the linked list? Does the starting point is 20? So if the starting point is 20, the head should be over here. So we can understand that this is the start point of the linked list. From this example, if we have 4 elements, so start point will be this 10, 20, 30, 40. What if we do not have this link, this node? So when we do not have this node, the start point would be this. Or if we make the head as 30, so start point would be 30. So without making you more confused on this, let's elaborate these things over the later stage of code, where you can get a better idea about the head. Head is nothing, just a pointer. It's like this. I just this is a pointer. We want to print 10, the pointer will be there. When we want to print 20, the pointer would be there. For 30, the pointer would be there. And for 40, pointer will be there. So where is the pointer? Define what is the current head or what current value we are going to print. So for now, let's point this thing, the head or pointer, to be none. So we have defined the head, which is nothing, just this. So let's I make it name as head, so you can get a better understanding what actually it is going to use. Now we define a function to the function which will add the node and link each node with each other, so we can create a linked list. So let's start with the appending or creating a node. So name it as add to last. What this function do? If we have nothing, a node is created 10. If we want to add 20 after 10 at the last, if we add one more node which is 30, so 30 would be placed after 20 and 40 will be placed after 30. So whenever a new node is created, it will be placed at the last in the linked list. So this function will do the same. We will collect the data from the user there. So because for the creation of node, we just need the data. So what we are collecting from here, and now we are creating a new node from this data. Now new node is equals to node.data. What it will do, whenever we've called this function will take an argument of as data, and data, let's say we provide a 10, so data would be the 10 and data will be passed in the node class. Node class get data over here as a 10, assign the data, and next is by default none. So our node will be created like this with a data 10 and then memory or next as none. So let's call this function. We create an object for the linked list and we call the function add to last and provide the 10. Once we provide the 10, this function get called. The main control will get over here with the value of 10. The 10 will be assigned to this data for creating the node, and hence we get a new node with a reference of 10 and memory as none, like this. So once the new node is created, we will check if self.head equals to none and do something, else we'll do something. Let's define what we gonna do in both the cases. Let's imagine we have a 10 as provided to create a node. This add to last function is triggered, and passing with the data as a 10, we create a new node. Right now we only have one node, right? And we have provided the information as a head at self.head is none, that our head is pointing to none. Says we do not have any of the linked list existing yet. Now we have to define to the head that we have a node, we had of our first node for the linked list. If our head is pointing to a null, it says no linked list is present. But after this line or this object, we have already created a node, and once we have created a node, we define that if our head is none, which is pointing towards none, defines that we do not have any of the node inside our linked list yet. So we says we have already created a node, so self.head equals to new node. So what we did from this line, we have shifted head pointer from null to head pointer this 10. Now our head is pointing towards this node, which is nothing, the node which we created now with the data as 10, and by default the memory location set to be none. Now we create another node with a element of 20. Again add to the last function will get over here. Data is nothing, just 20. So new node of 20, which I can explain from this graphic as to be none. After executing this line, a new node will get created with the value as data as 20 and the memory location is none. Now we check if head is equals to none. At the previous case, when we created our first node, at that moment head was pointing towards the none. Hence this condition got true and we have assigned our head to new node from this to this. But in this case, our head is already pointing towards this node. From this line we had already made the pointer head to shift it to the new node. So this condition gets false because our head is no longer pointing towards the none. Now our head is pointing towards our first node, which is 10 none. So what in this case? So we will define that if a new node, or we can duplicate this pointer, we define another variable as self.head. What this line do, it duplicate. Right now we have one pointer whose name is head. Now I have duplicated this pointer and name as pointer, which is nothing but this. We have duplicated the self.head 2 pointers. So I have created 2 pointers. The reason for this creating a pointer is whenever, because in a single linked list, this is a drawback that single linked list can be traversed in the unidirection. You can go from 10, 20, 30, 40, but you cannot trace back it reverse from 30 to 40, 30, 20, 10. You cannot. Hence, single linked list is a unidirectional linked list. It only traverses in a single direction from left to right, from 10 to 40. The major advantage of making a duplicate pointer is if I want to add a new node. So let's say right now we have a new node as 20, which would be this. If I made my head to this, pointing towards this, like this, I have made a new node and link this node and this node. But right now my head is pointing towards this particular node. Now I just want to print the existing node, what nodes and data it is in my memory location the linked list is holding. So for traversing or for printing the entire linked list, I just want to start from this, from here, from this to this. But as I told you, single linked list is a unidirectional. So from this point, I cannot go back to this point. So this is the restriction. So what I did, if I duplicate my pointer, so after 10, if I want to add any of the node, I will put my current node as 20 when I add a new node as 20. If I want to add another node, which would be 30, so I can make the pointer to the new node. So I can define node as a 30. Once I want to add one more node, because I am adding at the last. So this is how I got the information that currently my last node is this. If I add 40, my last node is this, because from this pointer I'm getting the information that yes, this is my last node. And if I want to print all the nodes, I cannot make this pointer back to the first. So I will use the head pointer to print 10, 20, 30 and 40. So this is the advantage of making the duplicacy of the pointers. You will understand more on this at the later part of this tutorial. So once we have defined our pointers, now check what would be our last node. So after that, the new node can be linked, because we want to link a new node at the last. So before putting the new node at the last, we should know which is already a last existing node. So we use the help of the pointer using while loop. So we say while pointer dot next. If pointer dot next exists, what is pointer dot next? Right now a pointer is pointing towards this node and current newly created node is 20 none. We say pointer dot next, check if pointer dot next exists or it is true. So we say the pointer which is pointing towards this node, pointer, and the next part is this. So pointer dot next, which is none. So this condition got false. No, the pointer of next do not consist any of the reference for the new link. So what we say, if the new node or the succeeding node do not exist, let make pointer dot next equals to new node. So what this line will do, if from this file, if pointer dot next, this is pointer, this is next, if the pointer does dot next, which should be true condition to get inside the while loop, but right now pointer dot next is none. By default this condition is not getting true, hence the loop will not get executed and directly we will land over this line. And what this line says, new node will have a memory address of 008. So what it will do, it will assign the pointer. Right now pointer is pointing to this node, so pointer dot next, which is nothing, just this, is equals to new node, that is the reference of the new node. So what it will be replaced by 008 from this line. Pointer dot next, which is this, is equals to new node. Now new node has the address of this. It is an example. Whatever the actual address would be there, it will get assigned to this. Here is an example of rough addresses. These are the memory addresses. These are not the actual one, but for the reference, these are the examples. So whatever the actual reference of this node would be there, it will get placed or assigned to this next. Now if we add one more node, let's say 30, again this function will go over here, and now the new node would be marked as 30. Again, if the self.head is none, because head is already pointing toward this, and this pointer has been destroyed, head is already pointing to this, else because this condition got false, the line come over here, head pointer equals to self.head. Again we have created pointer, a duplicate pointer for the head. Now pointer dot next, again pointer is pointing to this node, pointer dot next, which is nothing but this. Is this existing? I mean pointer dot next exists. This time it is not none, so the condition got true, and if condition goes true, the control will inside the while loop, and we write pointer equals to pointer dot next. Why? What line it do? If this condition goes true, that pointer dot next, which is this, if pointer dot next is not none, because this time it has some of the values, some of the reference of the its succeeding node, so this condition got true. And what we define, pointer dot next, which is nothing, still pointer dot next, pointer dot next, it's 008, defines to the pointer, which says now this pointer is pointing this memory allocation. And what it means, that means now pointer is indicating or pointing this node, hence this node gets connected because this node having the next reference of this node. And we have already assigned that pointer dot next, which was there, pointer dot next is equals to pointer that we have defined. Now the pointer would be this line sudo says that it's 008 equals to, which is nothing but or we can say p of this is now 008. So pointer dot next was this 008, and now pointer we have defined 008 to this, which means now pointer is pointing towards this node. Again this loop, one cycle of this loop has been completed. Again the pointers loop will go again to this line and check if pointer dot next exists. Now the pointer is this pointer dot next, which is nothing, the pointer dot next is none. This time this condition is getting false. So what this line will do, pointer dot next, which is right now this is none, will assign to new node. A new node we have 30 none. So in this time we will assign pointer dot next, which is this, to new node, and the value of new node is 015. which was previously none, and this time the reference of this node. So this has been updated. So this part is completed and the function will go out. So till now we have two nodes, 10, 20 and 30, one more node, because 10 has the data. This is the link for this node, this link has the data, this link has been node for this, and this link has data. Right now we do not have this node for write, so this would be the three nodes for our linked list for this time. So let's check it out. Let's create a function called show linked list. What it will do, it will print all the nodes and its value. Let's create a pointer sub.head. So once this complete cycle has been completed, this pointer is destroyed. So again we had a pointer towards this node. So what we did, we said whenever the show linked list function is triggered, a head will duplicate itself with a new pointer named as p. Now we will loop over all pointers and print pointer.data and separated by this arrow, and assign pointer to the pointer.next. So what it will do, we have duplicated the data over here, which is header and its duplicate pointer. Now it says while pointer, do we have any pointer right now? Yes, p is pointing to this node. So this condition goes true and the line comes over here, the control comes over here and says pointer.data, which is nothing, just 10. So this will print over here 10, and with this, so it would be like something like this. Once we have printed the 10, now it says pointer.next, which is this pointer have next this, again assigned to the pointer. It's just similar to what we had done over here. So what it is, pointer.next, which is 008, assigned to the pointer. So now pointer will come over here because pointer value has been updated as 008. Again the loops go over here. Again we have the pointers? Yes, because pointer is pointing to this node. So this condition goes true. It comes inside pointer.data, which is pointer and its data it's 20. So it prints 20 and something like this. Again pointer.next, which is this. If pointer.next is 005, we have assigned the pointers. So this value has been assigned to this pointer, and now this pointer points this node. Again, do we have the pointer? Yes, pointer is pointing to 30. Pointer.data, which is 30, like this. Pointer.next. Now in this case, the pointer.next is none, and this time, do we have the pointers? Yes, and the data has been printed as 30. Pointer.next, which is none, so pointer is assigned with a none. Again this pointers gets off over here and gets this like this. So we can consider this has been destroyed, and we will get the output like this. Okay, so we forgot to call this function. So once we add 10, 20, 30, now call this function. Let's run it again. See, it's 10, 20 and 30. Let's add one more node as 40. So again, let's find the same stuff again. When we created the 10 goes over here. When we created the 10, our first node is created. So let me make it all none. Again, a new visualization we can use to understand this better. So once the 10 is this function is called with the value 10, a new node is created with a 10, and again this should be over here, because when we start the linked list, again the linked list is had assigned with a none. Then we call this function with the value 10, a node is created with the value 10 and none. Now self.head equals to none, Yes, the head is pointing towards the null. So this condition goes true, and self.head equals to new node having the value. So you can see the new node value is 000. So self.head equals to 000. So the head will shift over here with the first node. After that, second function is called with the data 20. We got a new node with a data is 20. Self.head is null? No, because this time head is pointing towards this node. So this condition got false. Self.head equals to pointer. So we duplicated head to create a new pointer. While pointer.next, do this pointer.next exist? No. So this condition got false, and the line inside the while loop doesn't get executed. The control gets over here. New node which is 20 assigned to the pointer.next. So new node which is 008, this 20 is none, this 20 and none, the reference value as 008 we have assigned to the pointer.next, and right now the pointer is pointing to this node, and this node got the value at 008. Again, the function is called add to the last as 30, the value is 30. We got a new node. Self.head is equal to none. No, the head is pointing to the first node. So this condition got false. In the inside, we again created a copy of the pointer, because once the second node was executed, the pointer gets destroyed. So again, we have created the pointer. Pointer.next exists. Yes, pointer has the existing reference. So pointer.next equals to pointer. So 008 assigned to the new pointer, and new pointer start pointing towards this node. Again, this loop over here, do we have pointer.next? Right now pointer is pointing towards this node, so no, the pointer.next is none. So this condition got false. So new node is assigned to the pointer.next, and new node which is nothing with 30. So this is replaced by 015, and this pointer got destroyed. Once we call the 40, new node called created got 40, head is pointing to the none. Now this condition is false because head is pointing towards this node. Again, head duplicate itself as pointer. Pointer.next, do we have pointer.next? Pointer.next, yes we have. So we have assigned pointer.next to itself, so the pointer can move over here. Again, over the loop, does pointer.next we have? Yes, pointer.next we have. So we have assigned pointer.next to move further. Again, pointer.next we have. No, this time the conditions got false. So new node which is 40 will assign pointer.next, and pointer.next is not pointing over here. So we will assign new node, and the pointer will get destroyed because this while loop or this function has been over. So after creating node 40, it will call the LinkList function. So inside the LinkList function, we again copy the pointers. So head duplicate itself as P. Now see, do we have pointer? Yes, pointer is pointing to this node. So let's print a pointer.data which is 10, and pointer.next assigned to the pointer, which is now pointer.next is assigned to the pointer, so it refers to this. Again, do we have pointer? Yes, we have pointer. Pointer.data which is 20. Pointer.next is assigned again to the pointer, which is pointer.next, which is this, assigned to the pointer again. Do we have data? Yes, we have data. Pointer.data which is 30, and pointer.next assigned to the pointer, and pointer.next is 024. So assign pointer over here. Again, the while pointer, do we have pointer? Yes, we have pointer. Pointer.data which is 40, and pointer.next. This time pointer.next is none. So we assign pointer.next to the pointer, and again the pointer got over from here, and its value get none. And once this function is over, the pointer and head all are destroyed. And this will print all of our data, which is 10, 20, 30, and 40. So this is what about the linked list. At the last, I will conclude that linked list is a linear data structure which is combination of nodes, the nodes containing the data in the memory reference. From this presentation, I hope I can make you able to understand how linked list work and how each nodes are linked with each other in the different memory allocation, representing the data the single row. And linked lists are unidirectional, so you can print a linked list on a single direction. You cannot reverse its direction. We have multiple type of linked lists. So there are three type of linked lists: single linked list, double linked list, and circular linked list. Single linked lists are unidirectional, double linked list dual direction. Or double linked list is nothing, just one more attribute get over here is none. So like this only. So double linked list get one more memory space. So the mid part is data. This part of memory is referring to the next node after this, and this part of the memory referring to the node previous to this. So this is how double linked list is represented. And so due to double memory reference of the node, it can be possible to traverse front in the front direction and the backward direction in the double linked list. So we will discuss the double linked list in the next video.